Hello friends, welcome back. Today we'll discuss about hydraulic pumps. The picture on the right side shows the symbol of a hydraulic pump. We learned that in hydraulics, energy transmitted by the use of a liquid as carrier of energy from its source to its point of application. This liquid flow is created by the pump. Pumps used in power hydraulics are hydrostatic pumps. Pumps can be classified as hydrostatic and hydrodynamic pumps. In hydrodynamic pumps, output flow is decreased when we increase the pressure in the outlet. This is due to lack of positive seal against leakage between the inlet and outlet ports. Therefore, they are also known as non-positive displacement pumps. In case of hydrostatic pumps, there is a positive seal between inlet and outlet. They deliver a given amount of fluid in every revolution or stroke, irrespective of the pressure in the system. Therefore, they are also known as positive displacement pumps. The pump sucks fluid from a reservoir and displaces it to the outlet. Fluid then flows to the application through the hydraulic lines. The load resistance in the application opposes this fluid flow. As the pump is a positive displacement one, the fluid flow from it is continuous. Therefore, the fluid pressure increases according to the load resistance, and when it is high enough to overcome this resistance, the energy transmission takes place. Pressure in a hydraulic system is not created by the hydraulic pump. Pump creates only a fluid flow. Pressure builds up in the system if there is any load resistance opposing this fluid flow. The pressure rating of a pump is the maximum pressure it can handle or overcome. Now, how do you specify a hydraulic pump? Hydraulic pump is specified by its displacement volume, also known as geometrical displacement, usually in cc per revolution or cubic inch per revolution. It is also common that pumps are specified by their flow rates, liters per minute or gallons per minute. Q is equal to V into N divided by 1000, where Q is equal to discharge in LPM, V is equal to geometrical displacement in cc per revolution, and N is RPM of the pump shaft. It is also important to specify the rated pressure of the pump, which is the maximum operating pressure it can handle. Hydraulic pumps can be classified by design as gear pumps, vane pumps, and piston pumps. Piston pumps can be further classified as axial piston pump and radial piston pump. Pumps can also be classified by performance as fixed displacement pump, stroke volume cannot be changed, and variable displacement pumps. Stroke volume can be changed. Fixed displacement models are available in all types of pumps: gear pumps, vane pumps, axial piston pumps, and in radial piston pumps. Variable displacement is possible only with the vane pumps and axial piston pumps. That means vane pumps and axial piston pumps are available in both the models, fixed displacement as well as variable displacement. Gear pump. Please look at the picture. We will discuss about external gear type. It consists of two gears of same size, one drive gear and one follower gear. They rotate in the opposite directions. Teeth in mesh work as a seal between inlet and outlet. When they unmeshed, partial vacuum is created and sucks fluid from a reservoir. Fluid occupies the space between the teeth, which carries it to the outlet. Displacement volume is approximately equal to sum of the tooth spaces of the two gears. This displacement volume for a given design cannot be changed, and hence gear pumps are fixed displacement pumps. Gear pumps can be classified as internal gear pumps and external gear pumps. We have already discussed about external gear pumps, where two identical gears with separate shafts rotate in opposite directions. Internal gear pumps consist of two gears of different sizes with one rotating inside the other. Vane pumps. As shown in the picture, vane pump consists of a cylindrical rotor with movable vanes inside its slots. Rotor rotates against a camring. Centrifugal force and fluid under the vanes hold them out against camering, which acts as a positive seal. As the rotor rotates, at one point a partial vacuum is created. Fluid from the reservoir is sucked, which occupies the space between the vanes. Vane pumps are available in both models, fixed and variable displacements. Variable displacement is possible by adjusting the eccentricity of the camering. Next, piston pumps. Piston pump creates a fluid flow by the reciprocating movement of a piston. Piston pumps can be classified as axial piston pumps and radial piston pumps. Axial piston pumps can be further classified as inline piston pumps and bend axis piston pumps. Inline piston pumps. It has a number of pistons, usually odd number, arranged axially in a cylinder block. Cylinder block rotates and pistons inside reciprocate against a stationary swash plate kept at an angle. The reciprocating movement of the pistons make the suction and delivery strokes. Both fixed and variable displacement models are available in inline piston pumps. Variable displacement is possible by changing the swash plate angle. As you can see in the picture, the inclined position of the swash plate causes the pistons to reciprocate. When this angle is 0, swash plate will be in a vertical position and the pistons will not reciprocate. Flow is 0. When the angle is maximum possible, flow will be the maximum. In some designs, the swash plate angle cannot be adjusted, which makes them fixed displacement pumps. In some design, this angle can be adjusted, which makes it variable displacement pump. Next, bend axis piston pumps. It has a number of pistons, usually odd number, arranged axially in a cylinder block. As you can see in the picture, the cylinder block and pistons are at an angle to the drive shaft and a thrust plate. The cylinder block is connected to the drive shaft by a universal joint. Drive shaft, cylinder block, and thrust plate all rotate. The reciprocating movement of the pistons make the suction and delivery strokes. They are also available in both fixed as well as variable displacement models. Radial piston pump. Pistons are arranged radially to an eccentric shaft. Springs under pistons hold them against eccentric shaft. A rotation of eccentric shaft causes the pistons to reciprocate. Fixed displacement only possible in a radial piston pump. Pump efficiency. Volumetric efficiency. The actual output of a pump is less than the theoretical output due to many factors such as leakage losses. Volumetric efficiency is equal to Q actual divided by Q theoretical, where Q actual is equal to actual output flow rate and Q theoretical is equal to theoretical output flow rate. Hydromechanical efficiency. The actual torque to drive a hydraulic pump is more than the theoretical torque because additional torque is required to overcome the frictional forces. Hydromechanic efficiency is equal to T theoretical divided by T actual, where T theoretical is equal to theoretical torque to drive and T actual is actual torque to drive. Overall efficiency. Overall efficiency is an indication of how much mechanical energy supplied is delivered in terms of hydraulic energy. Overall efficiency is equal to volumetric efficiency into hydromechanical efficiency. Comparison of pumps. Here we are comparing different types of pumps with their three parameters, pressure, displacement, and overall efficiency. Gear pump. It can take maximum 250 bar pressure and displacement up to 80 cc. Efficiency ranges from 75 to 90%. Vane pumps up to 175 bar operating pressure, 10 to 150 cc per revolution displacement. Efficiency from 75 to 90. Next, axial piston pump. It can take very high pressure up to 400 bar. Displacement also very high from 10 to 2000 cc per revolution. and efficiency 85 to 90, which is also very good. Radial piston pumps, so it can take extra high pressure up to 700 bar, but its displacement is very low, up to 20 cc per revolution only. Efficiency is 80 to 90%. Now please note that the displacement values given above are that of standard pumps available in market. Efficiency also varies with different brands. Data given above are only for general understanding. Leading pump manufacturers. Some of the leading pump manufacturers are Rexroth, Vickers or Eaton or Danfoss, Parker, Harvey, Yukon, Linde Hydraulics, Hydock, and Sun Hydraulics. Exercise 2. Question number 1. Differentiate between hydrostatic and hydrodynamic pumps. Why hydrostatic pumps are called positive displacement pumps and hydrodynamic pumps are called non-positive displacement pumps? Give examples. Question number 2. What is the function of a hydraulic pump? Number 3. Differentiate between fixed displacement pumps and variable displacement pumps. Question number 4. Why variable displacement not possible in gear pumps? Number 5. What will happen if we keep the switch plate of inline piston pump at 0° angle? Question number 6. Which type of pump do you select in each of the following applications? In each case, drive motor RPM is 1500. A. Required flow is 50 liters per minute and the maximum working pressure required is 200 bar. B. Flow required is 200 lpm and working pressure required is 300 bar. C. Required flow is 200 lpm and maximum working pressure required is 100 bar. D. Required flow is 3 lpm and maximum working pressure is 700 bar. Thank you for the kind attention. If you like this video, please subscribe to support and get more videos on not only next sections of this course but other topics as well.